Hello students, this question is taken from test series 5 EE from the subject power system, from the topic transmission and distribution, and it is the second part of link data question. The previous question we have calculated the value of total voltage drop, that is VD is equal to 5.546 is and the angle 25.64, that is the voltage drop across the distributor. In this we have to find the value of voltage at the far end, so we have to calculate the voltage at the far end. This is the voltage at the far end. We have to calculate the value of voltage at far end. In order to calculate the value of far end, we know the value of voltage, that is voltage drop in the distributor VD is this one. After converting this rectangular to polar, we'll get the value of 5 plus j 2.4 volt. So the formula to calculate the value of voltage at the far end, that is total voltage, that is voltage VA, that is 240 volts, voltage drop across distributor, that is VD, plus voltage at the far end. This is the formula to calculate the value of the total voltage. In this, the total voltage, this is the formula for total voltage. We have to calculate the value of voltage at the far end. So we know the value of VA and VD. Substitute the value of VA and VD, then find the value of VF. That is VA is 240 volts, given voltage at the starting feeding is 240, and VD from the given the voltage drop of the distributor is 5 plus j 2.4 volts plus voltage at the far end, which is nothing but, in order to calculate the value of VF, first we'll do the squaring on the both sides by common this 240 is equal to 5, make this is j square is nothing but minus 1, so 5 plus VF, say this is 1, and j 2.4. Now if you do this one, nothing will be the same from the previous, so now you do the squaring on the both sides. If you do squaring on the both sides, you will get 240 square, 5 plus VF square, and j 2.4 whole square. See, which is nothing but j square is nothing but minus 1. If it is in the modulus, then it will be the plus, then it is 2.4. 240 square is equal to voltage at far end and plus 5 whole square plus 2.4. So 240 2.4 square. The value of 240 square minus after VF plus 5 is equal to 240 square minus 2.4 square. After that we'll get the value of 240 square and 2.4. After solving this value, we'll get the value of voltage at the far end, that is equal to 234.98 volt, which is the option C. In this session we have studied about how to calculate the voltage that is on the far end by using the value of voltage, supply voltage, and the voltage, that is voltage drop in the distributor. Thank you.